Hello there. Welcome back.
How was lunch? Dinner? Siesta? Whatever. We had a short one.
It was short, but good.
But good. Yes, definitely.
And now we're going to get straight back into the next session. So we've still got a lot we want to go through this afternoon for us and our time. So we're going to start now with the next session. The reason why we just did the file storage before, there is, despite appearances to the contrary, a plan to all of this.
Oh.
Yeah, so the next one is about the application lifecycle, and an integral part of that is the ability to store stuff at the appropriate time. So,
Oh, well then perfect.
yeah, so there you go.
So it's like you actually planned this out.
I know, unbelievable, but true.
All right.
So here we go. This is all about the Windows Phone 8 application lifecycle. So let's just have a quick check of where we are in the schedule.
Thank you.
Sorry. There we go. Session 5, Windows Phone 8 application lifecycle. So the rest of the afternoon here we've got pretty short sessions on the background agents, tiles and lock screen, push notifications, and then we wrap up with all the camera and sensors and contacts and appointments, all that kind of good stuff. And we will, at some point, eventually get on to all that stuff tomorrow. Right, so this one is all about the Windows Phone 8 program lifecycle. What happens when an app is launched and when it closes, when it goes deactivated, what all these things mean, the dormant and tombstone state, and stuff relating to that. Now, if you are have some experience of developing for Windows Phone 7, most of this has not changed, apart from the major new feature, which is Fast Application Resume. So that's part of this deck as well. So keep watching. This diagram actually sort of sums up pretty much the life cycle. So a Windows Phone app transitions between different application states. User starts an app from the start screen, the apps menu, or from a deep link on a secondary tile, a reminder, or a speech input, file or protocol association. Plenty of ways to launch an app these days. And as we've seen, when the user presses the back button whilst on the launch page of the app closes. So we've gone from not running through launching. We've been running briefly, then we've hit the back button and we're out again. Now, while we're in that running state, if the running app loses focus by the user starting another app, getting an interruption such as a phone call, or the lock screen coming up after a period of inactivity, then the app is suspended, which means for us being made dormant. Dormant apps are kind of cached for fast reactivation. If the cache becomes exhausted, then a dormant app may become tombstone. So from here you've gone from the dormant box down to a tombstone state. Apps may be resumed from either a dormant or a tombstone state, but depending on how you're being resumed, you as the developer have more or less work to do. And this is really what this session is all about. And on each of these events, when you're being launched, when it's closing, when an app is being deactivated, when it's being reactivated, there are events, application lifecycle events that fire. And in the project templates, you will find when you create a new project, in app.xaml.cs or .vb, event handlers for all these events are already in place. So they're empty, of course, and it's up to you to plug in the right behaviors to implement the kind of application lifecycle support that you need. So this is a lot of work went into this demo. This is the most complex demo that I could possibly conceive of. So here we go. We're in Visual Studio. I'm going to create myself a new project. Prepare to be stunned.
I'm frightened.
Yeah, you should be. You should be. And we're going to create just a single page Windows Phone app. There we go. Yeah, Windows Phone 8 can be. And when that loads, I'm going to go off and just show you in the app.xaml. So every application has an app.xaml. And actually, if you look into it, by default, here is the actual XAML that is hooking up these event handlers. So, and those event handlers are all in our app.xaml.cs, the code file. This is the root of your application. And there's an application not launching. I'm going to put a breakpoint on there. I'm going to put a breakpoint on there. Are you seeing where this is going?
It's a clever use of breakpoints.
Thank you. I'm going to run it. And, yeah,
Wow.
there you go. Isn't that amazing? So this obviously is the event that fires when we are launching. And we can continue it. And our stunning UI appears. And we're on the launch page of the app. And we can choose to close it like that. Oh, I did the wrong...
Nothing happened.
This is the simplest demo you could possibly conceive to man. And, of course, nothing happened because I didn't put a breakpoint on the closing. That's what I should have done. So, there we go. Now, this will not be a surprise to anybody. So, there we go.
I wonder what's going to happen this time.
Yeah, we're going to amazingly hit the launching. Woo!
Is that like form load?
You could think of it like that, yes. And there we are, we're closing. So, what you're going to want to do, of course, is put your application logic to load any persistent data from, deserialize your data from a XML file or something in the loading. And then when you're closing, this is your last chance to save anything. So you want to make sure at the point that this application closing event fires, that's where this is your last chance to make sure that your application's state has been saved and your app is ready to go again the next time. That's the important learning point of that. Yeah, it's a crummy demo, but don't worry, we're going to up the intensity.
Oh, good.
All right, back to the slides. So yeah, of course, what we saw there, like I said, this is a good place in application launching to load your content, and closing is where you need to save it. Although actually, from an app design point of view, it's probably not a good idea to save or to wait until that application closing. That is your last chance.
Right.
But typically, any page in your app will be making some incremental changes to your application state, and you probably want to save as you go along. But that is your last chance to do it. Just a confirmation, that final bullet point about the debugger behavior, which I called out before, that it keeps on running in Visual Studio.
That's really convenient.
Which is so we can test all these application lifecycle things. Now, of course, if you are used to doing Windows Forms development, yeah, this kind of stuff, form loading and closing, this sort of thing, this makes perfect sense to you, and you wouldn't expect anything in between that. But, of course, an application running on a smartphone is not a desktop application. It's not running on a PC. Smartphones are limited capacity devices. They have battery life. Their most precious resources are battery life. And they need to manage that battery life in a way that ensures a good end-user experience. The way Windows Phone and other competing smartphones do this is to ensure that the foreground application is the one that has total control of the phone's resources, and as soon as it loses focus, it's deactivated and stops using resources. You have to write your applications, have to deal with being deactivated and then being reactivated again from this state. So let's take this this application a little bit further, and so let's just remove that one. So if remember we've got breakpoints on our application launching and application closing, and it's still running from when I ran it before. So let's just stop it and start over. Here we go, and it's launching, so yeah, application launching as you'd expect. And now we're running. Now what happens when we lose focus? And actually there's a couple of ways of making it lose focus. We could simply hit the Windows key.
Oh, that's a different way.
Yeah. Now, the application closing event didn't fire. The app has not closed.
Okay.
But nor is it running, nor is it using any resources. So hitting the start button has made the current application dormant. It's in the background. Now, if I just simply go back again, it will get reactivated. And we can just confirm that by putting a couple of breakpoints on those methods as well, just so that we can confirm that that is that behavior. So get our emulator up. So now I'm going to deactivate it. Here we go. We're going to deactivate it, let it run, and we can reactivate it by just going back, and here we go, we're reactivating that application. And it back to the foreground, there we go.
So other phone platforms that don't follow a paradigm like this, you might be out of battery life by lunchtime.
That could potentially happen.
Okay.
Yes, that's
all right.
Yes. So those that's a very quick and high-level look at the key events that you need to worry about. This will be no surprise to any of you who've done any of this before, but for you, those of you who are watching this who are new to smartphone development, these are the key events that you have to worry about. All right, so let's go back to the slides. So there's a number of ways that a user can make your application go dormant at any time. The lock screen could come up because they haven't used the phone for a period of time. They could get a phone call, sort of, hey, let's not forget these devices are actually for making phone calls and getting phone calls. It's easily forgotten.
That's crazy talk.
That is crazy talk, but it's true. Or the user could press the start screen, go and run another program. That's actually what I did there, is just to hit the start button to go to the applications menu or the start screen, and that you could start another application. So all of that is ways that that this could happen. But what you need to, the most important thing to remember here is that at the moment that your app is made dormant, you cannot look into a crystal ball and know what's going to happen. You don't know that it's going to be reactivated. You don't know that.
Right.
The user could turn the phone off completely while it's in a dormant state. That could happen. In which case, the key message here is that you cannot wait until that application closing event to make sure that any state that has changed in your application gets saved away. So the key message here is that you have to treat an application deactivated event effectively exactly the same as an application closing event.
Definitely.
Because if your app is dormant, and you can see on that diagram, if it goes dormant or tombstoned, there are a number of ways that it could get destroyed and never come back. And you don't get an event when that happens. So you have to treat that application deactivating event as similar to a closing. You need to save any persistent state down into your persistent storage. Very important point. So you need to treat it the same as closing. You have like up to 5 seconds to do any tidy up in either of these events. If you take more than 5 seconds to do your sort of shutdown logic, you will get forcibly closed by the OS. But 5 seconds is a pretty long time.
Right.
And when it comes back from dormant, it will automatically resume at the page where it's deactivated, and anything that was in memory is completely retained. What actually happens is that when it gets deactivated, the OS takes a snapshot of your working memory and it stores it in a cache, and that is what a dormant app is. It's kind of taken a snapshot, it's sitting there, and when it gets reactivated, that snapshot is just loaded back into working memory, and the OS just picks up and away we go, just as if we've never been away. I'll come back to that in a moment, because there's a couple of instances where there are a few things you need to think about. But so this is a diagram that illustrates what's going on. So here our user has started our application, which is that one shown, the main page one in black, and underneath that we've got the previous app we were running has been made dormant, which looks suspiciously like the recipe page on the Contoso cookbook.
It's seen better days.
Yes, it's looking a bit pasty-faced because it's been made dormant. It's sitting there and waiting to be reactivated. We could go to the second page in our application, and nothing much changes. We've still got our dormant Contoso cookbook under there. But then the user could decide, oh, you know what, I'm going to launch a different app. So our app is made dormant and sits alongside the Contoso cookbook, and now the user is running the calculator, for example. Right. And the user does their calculation and then closes the calculator when they're done with it, hits the back button, and at that point our app gets reactivated and we pick up. Notice we pick up back on second page, and that's all handled for you automatically.
That's nice.
It's nice. Now, this back history stack, so far I've been talking about, hitting the back button and going forwards and that sort of thing. That isn't the only way of resuming an app. So there is this thing called fast application switching, which was introduced in Windows Phone 7.1. If you do instead of just hitting the back button briefly to move back to the previous application, if you do a press and hold on it, you get this fast launcher, this launcher UI, where you see thumbnails of all the applications that you have been running, and you can swipe between them and select one, and that can be reactivated. So the point here is they can be reactivated sort of out of sequence, if you like. So there's this app history stack, and you can be selected from anywhere in that app history stack. There are 8 slots. There were 5 in Windows Phone 7.1. There's now 8 slots in that application history stack. And users and apps in that history stack, they could be dormant, or they could be tombstoned, and they can be reactivated from either of those states, and they will appear in that history stack. Their thumbnails will appear on this. And like I said, there's up to 8 slots for those. Now, so this dormant tombstone, what is all that about? So I've said that we take this memory snapshot, and it sits there in the dormant area in this cache, and if the user chooses to relaunch your application, either by navigating back to it or by choosing it from the fast application switching launcher, then it'll just be loaded into memory, and away we go. But the cache is not, it's not unbounded. There is space in there for a number of applications. So if the cache becomes exhausted, so every time your application moves further, older and older in the history, so the user goes and starts the calculator, then they go and start the Contoso cookbook, and then they go and start some other app, and then they start some other app and some other app. And all the time a new app is added on top of this history stack, your app is moving older and older in the history. And at some point, the cache for these memory snapshots is going to be exhausted.
Right.
And at that point, the oldest application in the history stack, its snapshot is discarded, is thrown away, and the app is said to become tombstoned. So a tombstone application can still be resumed because the OS saves the page navigation, saves what pages have been visited in that app. And also there is a special cache, which we'll talk about in a minute, which are some state dictionaries where you can store some data. And it can be resumed from that, and it will restart at the correct page. But anything, all this memory, all these objects that were in memory, gets thrown away because that all gets discarded.
So your old app could go from a cache hit to a cache miss.
Yeah.
In CPU terms.
You said it so much more succinctly than I was saying it.
Okay.
That's exactly right. A cache
Yes.
miss, in which case you have to do more work in order to get your application back. And the key thing to remember is, as an application developer, you need to do whatever you need to do to get that application back to the state it was in when the user left it.
Right.
And that takes a little bit of special organization, which we're going to go into now. So this is a diagram that just illustrates that process. Here we go. The user started the calculator, and we're moving, and then they start something else. The lock screen comes up, and now the calculator is dormant as well, and our app is in there, and so on and so forth. And at some point, we get tombstoned. Our memory snapshot has been thrown away. Now, of course, the user could start unwinding the stack at this point. So, you know, we've gone off for the people hub, and we've got rid of that, and we've got rid of and all the time our application, you can't sort of untombstone. That's one thing to remember. You know, once that memory snapshot has been thrown away, you're in a tombstone state forever then until something like this happens. The calculator gets stopped, and then we can be resumed from tombstone, and we start over again. But you're going to have to write some code at this point. You're going to have to write some code.
Rehydration.
So you need to know which state you're coming back from, and that is quite easy. So in both cases, the application activated is the event that fires, but it has an activated event args, and in that is a property called isApplicationInstancePreserved. If that is true, we're being reactivated from dormant, so all our objects in memory, the app is kind of exactly as we left it, so generally you don't have to do very much. If it's false, then we're coming back from tombstone, and then you'll need to reload your data and set everything up again and get things working. So you need to debug this thing, of course. And the way you can do that is go into the project properties on the debug tag, and there's a tick box on there, a checkbox you can set to, instead of being dormant when you get deactivated, instead it's going to tombstone your app. So this allows you to debug these situations. So
I'd like to know the difference.
Yeah.
We need to see it.
Okay, let's go for a demo.
Excellent. That's what demos are for.
Okay. Ooh, there we go. So here we go. So I'm going to now open this app.xaml.cs file. And this is, again, a very simple demo, just to kind of drive home the message. You will notice that there is a private string in here, a member of the app, app class, and it is initialized, when the app is first started up, it will be initialized to a just loaded value. And then we're going to run it, and of course we're going to hit this breakpoint at the beginning of application launching. And at this point, obviously, app state, because we haven't been through this line yet, app state still has the value of just loaded. And of course, we're going to go through here, and it's going to change the value of app state to been launched. And now we can let it run. And now I'm going to just make it dormant and restart it. And now we're into application activated. The application activated event args has application instance preserved is true. So at this point, Rob, what
Yes.
will app state have in it? What would the value of app state be?
So it's dormant.
Yeah.
So would it be been launched? Being launched?
Been launched, exactly, yes.
Because it was freeze dried in memory and
Yeah.
then it just came right back to you.
That's right, exactly so, exactly so. Yeah. There we go. Stunning demo or what? Now let's just close that and just hit that flag in the properties.
Yes.
Solution Explorer. Go from the properties. Here we go. This is the debug tag. I'm going to tombstone upon deactivation while debugging now. And we're going to launch the app again. Same thing happens obviously initially. So we're going to hit the breakpoint. There we go. App state is currently just loaded, and then it's going to step through this line, and it's going to be been launched. Okay, so now, and then we let it run. And here we are, our stunning UI application is running.
Somewhere
out there. There we go, there it is. And now when I deactivate it, this time, because I've hit that switch in the settings, it's going to be tombstoned. It can still be resumed. Oh, by the way, there's the launcher. Let's do it. Let's resume it from here, from the fast application switcher. This time we're resuming from tombstone. So we still hit application activated, but this time its application is preserved is false. So, but what will app state have in it now? Hang on, let me just show you.
Give me a hint somewhere.
Yeah, there you go.
Oh.
At this point, what will the value of app state be?
So we were just loaded. We've been launched. And then we were deactivated.
We were tombstoned.
We were tombstoned.
Threw away the state of the objects.
Is it been activated?
Not yet.
Not yet.
Just loaded, because what's happened?
It's like we started all the way over.
We started all over again.
Ah.
Yeah, and this is the good point. Thank you so much, because actually what we need to do is make sure that when we come back from this, we bring back our state, which would have been in some way making sure that at this moment in time, app state would actually have a value of being launched, which is where we left it when we got deactivated.
But it's not freshly launched.
No, but we need to maintain the illusion that that is what is happening.
Right.
Sorry, not freshly, that we are resuming and we pick up just where we were. Now this example is too simple to illustrate just what we need to do. So I've got another demo coming up which will make that a little bit clearer. Okay, so yeah, back to the slides, please. Right, just let me, yeah, okay. Yeah, so just drill this home again. When we resume from dormant, we resume exactly where we left off. Everything that was in memory, all the variable settings, everything that we'd set, like that app state variable, comes back just as when we left it. The only thing that you will need to worry about is if you've got some time-dependent logic in there. You need to sort of, change timers and counts and that sort of thing. Networking calls, that's the other thing as well. You've made a call, you haven't got the response back, so there's a little bit of stuff you need to do around that. Now, when an application is resumed from tombstone, though, sure, it comes back at the right page, But anything that was in memory, any objects that had been loaded, anything that was in memory, objects with state in, everything had been lost. Everything's lost. So you need to load your data up from persistent data, deserialize your data again. So you've got to reinflate your in-memory objects, and get all that right, so that you can get the state back into memory and get the application back into a working state. So essentially, do the same stuff you do on application launching, with the added complication, if you like, that we're starting on some page, arbitrary page, and we want to make sure that we try and get this illusion that we've never been away. So this makes the raises the question of, what about, say, think of an example where you had a page where the user was entering new details of some kind of object, some record that you were going to store away in a file or something, and they had got halfway through doing that information, and then at that point the application was suspended and made dormant. That's fine. When it comes back, everything's still in memory, so any controls that they had filled, controls they'd filled in already, they typed some text into a text box, that all comes back because it's all just still in memory, so we can pick it up and it's great. But if you've been tombstoned, all of that transit data that hasn't been saved away yet is lost completely. So you can end up, all the data that they had painstakingly entered is lost. So this is where the state dictionaries come into play. These are really for transit data, and it's all about maintaining this illusion that we've never been away. So when a new these state dictionaries are associated with a particular running instance of your app. So when the app is destroyed, closed, whatever, any state dictionaries go away. So they're just about allowing you to store transient data in them that you can pick up. Let me show you.
It's another good user experience thing.
It's totally a user experience thing. Yeah.
Keep them happy.
Yeah.
You don't want to lose all that work they did.
No, exactly. Yeah, I mean your permanent data, you'll have deserialized the data from files. So anything they saved last time they did a complete run of their app, not a problem. But stuff they were halfway through, yeah. And it's also more subtle stuff like that.
Like a web page that doesn't submit after you filled in a whole bunch of...
I hate that.
I hate that too.
I hate things. Pet hates. Let's talk about hates. So I hate that when you're in like a shopping app on the web and you have done a search, and you've got a big long list of things and you're scrolling down it and you find an item in the list down there and you think, oh, maybe that's the one I want to buy. So you click on that. It takes you to the details page. You read the details and think, no, that's actually not the one I want to buy. Right. So you go back and you're back at the top of the list again. Oh. I hate that.
It should remember. Yeah. It should care about you.
Yeah. So
we care.
This is the problem. We care about the details. This is what we're talking about, caring about the details.
That's right.
Mediocre is not good enough.
Not good enough.
Yeah. So what's going on here? Right. Yeah, so there we go. New instance, the state dictionary is empty. So yeah, this is the application state dictionary. There's actually two application state dictionaries. There's one that's application-wide, where you can store stuff, and it's just a dictionary. So you create a key with a string value, and you store some value in an object in it. Any object that can be serialized can be stored in the state dictionaries. And then when you set, this can be set in the application deactivating method, and then you could restore it to memory when you come back from tombstone. So you would, but the actual real one you're going to use more than likely is the page one. So this is the one where we are halfway through doing something on a page. So you are going to want to store in the state dictionary stuff that the user is doing halfway through. So here's an example of on navigated from. I've already talked about on navigated to, which is the method that fires when you come into a page. There is, you will not be surprised to hear, an on navigated from as well.
Unbelievable,
isn't it? And that fires when you leave the page. And there's a number of ways you can leave a page. You could be navigating forward to another page. So that's a navigation mode.forward. You could be navigating back. The users hit the back button. They're going back to the previous page. So that will be navigation mode.back. And if it's neither of them, you're probably being deactivated. So you're still leaving the page, but it's not a forward or a back navigation.
So this will still fire?
And this will absolutely will still fire.
Okay.
And this is your trigger for sticking some stuff, the transit data, into the pages state dictionary. And then when you come back, so now we're going to be reactivated. And if you remember, you come back at the page where you left. Right. So it's going to be this same page is going to be reactivated. And in the on navigated to, you'll have some logic that says, have I got something in my state dictionary with a certain key? And if there's something there, in this case, incomplete entry, you can say, aha, you'll say. Clearly, I am being reactivated from a suspended state.
Clearly.
So you can fill in the control with the half-completed stuff, and your user will love you because all that data that they'd entered is still there. So this is the pattern that you'll need to do. And I've got an example of this.
Of course you do.
Of course I do. Now this is a more interesting example. So we're done with these simple little samples. Let's do something, a real one.
I can feel the intensity increasing.
Yeah.
Could you hear that in my voice?
Mm-hmm.
Yeah.
Yeah. So.
Calm down, bro.
All right, I'm going to try to calm down.
So yeah, we got a tombstone one. This is an example of one that doesn't do what we want. Just to illustrate the problem. This is the captain's log again. Yeah, and this guy. So we launch it. We've got no entries at the moment, and we can put an entry in it, and life is good, and we can save it, and we can close it. And if we run it again, our application launching and closing logic is good in this application. So we'll come back and asteroids is there. So
it's there. That's
it's amazing.
amazing.
But now, if I go into here and we start a really, I can even spell it right, really long entry and so on, so forth. And then if we deactivate and go back in, it's gone.
Oh.
That piece of genius prose I was working on is completely gone.
Then depression sets in.
Yeah, exactly.
There.
Now this is that's the default text. Yeah. So so there's nothing there. My really long entry's gone. So this sucks. We need to fix this. So the one that fixes this, that's because we don't have any of this this port in it. So I'm going to open the one that is the complete version with does everything beautifully. We're still tombstoning when we're deactivating. So we can run the complete version. There we go. Asteroids. And I'm now going to... Now we're going to... We've just navigated to the second page now. And we're now on Navigator 2. This is a normal entry into this page. So I'm just going to step through it. We're going to look in the state dictionary. Have we got an incomplete entry in there? No, we don't. This is the first time we visited this page. So then we just let it run. And now this time I can put a really, I'm not going to bother about the spelling, and so forth. We're going to tombstone because we're deactivating. So on navigated from is going to fire. We're going to step through this. Which kind of navigation are we doing? Well, it's neither of them, so this must be a deactivation. So now we're going to store it away in the state dictionary. And our application is deactivated, is tombstoned. Right. So a user's going off and doing some other stuff, running some other apps, taking a phone call, sent an SMS, done stuff. And then eventually they think, oh, hang on, I was halfway through doing that captain's log thing. So we go back and we reactivate it, and we're on Navigated 2 on that page now. And we step into it. Let's scroll this down a bit. Does the state dictionary contain a key of incomplete entry? Oh, yes, it does. So we fill in our entry and we let it run, and there we go.
There it is.
There it is.
It's like magic.
Yeah. Now, it's not. There's still room for slight improvement here, because if I was being really perfectionist, I probably would save whatever the focused control was in the state dictionary as well. So not only would we put the value in, but we'd put the focus back as well. But hey,
oh, that'd be very...
an exercise for the reader to finish that off.
Do that at home.
Yeah. Yeah, and like that long list thing, it's really good to store things like the current position in the scroll position of a list. So there's plenty of examples online to show you how to do that. And that's the kind of thing that you should be using this state dictionary for. So you're maintaining the experience.
Don't disappoint the user.
No. Now, it could be argued, actually, with 1 gig phones, the new super greeter phones, being tombstoned is probably not going to happen very often, in all honesty. But there are going to be 512 meg phones, lower spec ones.
Right.
And so on the lower spec phones, and actually the memory footprint of apps has grown a little bit in Windows Phone 8 because of these high resolution images and that kind of stuff.
So people are building apps that are more than 20K now?
Yeah.
Oh.
Yes. So,
I
yeah.
thought this was phone development. Okay.
Yeah.
All right.
So there you go. That's that's kind of the state dictionary stuff. All right. Let's go back to the slides. Now, allied to this is instead of sort of talking about when you get deactivated, normally, as we've seen, when the lock screen comes up, you will get deactivated. So, and this is different. So the number of ways you can get deactivated. User starts another app, they get a phone call, they get an SMS, they go to hit the Windows button, they go and run another app. All of those things are reasons why your app will get deactivated. But the one that, if the lock screen comes up, so it's just the user doesn't use the phone for, and this is configurable in the settings. So it could be like 1 minute, 3 minutes, or 5 minutes. So when the phone has not been used for a period of time, then the lock screen will come up, and by default, that is also a situation where your app will get deactivated.
Right.
Now, so this is this idle state, as it's called. The phone detects the idle state, and then the lock screen is engaged. And you can, as an application, you could choose to disable that behavior and keep running under the lock screen. It's not something you're going to want to do very often. Typically, I have done this in apps where you're doing a big data download or something. You're downloading a series of records, and you don't want to have that interrupted. So upon being deactivated, in this case anyway, you can just keep running under the lock screen and finish that off.
Maybe if your device was connected to the mains.
Yeah, well, that's another, yeah, that's right. This is Mr. Miles's advice here. They're saying this is strong magic. So all this sort of stuff sounds great. Yeah, why not just turn it on? But of course, only use this if you really need to, because this is all about, you've got to buy into this idea of maintaining the user experience. And that means not creating apps that are going to flatten the battery.
Right.
But
you can say flatten the battery now that we have UK English in there.
Yeah. Oh, is this something you don't say?
No, we don't say flatten the battery.
You'd flatten the battery, yeah.
All right. That's okay.
Yeah.
It's okay now. It's part of the platform.
Good. So anyway, if you want to keep running under the lock screen, you just have to put this line of magic into your code, disable the idle detection mode, and when you're done with whatever it is you're doing you don't want interrupted, you just simply enable it again. Of course, what you don't get is any activated or deactivated messages when this happens. But also note that other point, that your application will still be deactivated if the user presses the start button. So this is just for under the lock screen. Now, you may want to know, of course, when you are getting the lock screen has come up, because you could stop trying to update the UI, for example. You're still doing something in the background, and you get this root frame obscured event. So this is how you would detect that you're actually in an obscured state, and it fires whenever you get anything that obscures your UI, toast message, lock screen, or an incoming call or something. So you can actually know when that is happening, and you can modify your application's behavior accordingly. Now, testing this, how do you test this? Well, it just so happens there's a new bit of thing in the tools, which is the simulation dashboard. And if you scroll down near the bottom, you can see there's a couple of buttons that are useful for this kind of thing. One is to trigger a fake reminder. You can fire a reminder off in the emulator. And the other one is to put the lock screen up on the emulator. And actually, we'll use that in when we look at the lock screen notifications to test that in the session after next. Now, that's the end of that. Let's just talk about, this is the big new feature in Windows Phone 8, Fast Application Resume. Now, by default, whenever you go to the Programs menu, even if you've got a copy of Contoso Cookbook that is suspended, and the user then goes to the Programs menu, finds Contoso Cookbook and taps on it to start it up, by default, that will always launch a brand new instance of the app. And the suspended one will get destroyed. And the same is true of any other way that you launch an application, such as from a deep link on a secondary tile, from a speech command, from other new features such as the app-to-app communication, file and protocol associations. And all of these are similar things. They all launch a new instance of the app, and your old one gets destroyed at that point. You can change this behavior. And actually, this does differ from Windows 8, for example, which normally resumes that suspended instance. So you can give your Phone 8 application Windows 8 kind of behaviors using this fast application resume capability, which in any of these instances where you would normally launch a new instance, instead of that, if there is a dormant version, it will reactivate it, which gives you really fast start, of course.
People like fast.
So, you will not be surprised to know I have a demo.
Get out of town.
That's right.
I'm thrilled.
It's not a complex demo, so don't get excited. Yeah. So,
You could if you want.
go for it. Go for it. Oh, yeah, they're getting restless in the back there.
They are.
Yeah.
Our producers are getting restless.
Yeah.
Gelman back here is having problems.
So this is the same thing. You've seen this before. So we're going to launch the app, and you've seen all this before. So our app state variable at this point in time has been initialized with the value just loaded, which is what it gets when you get a new instance of the app class created. And then, of course, we're going to do the same old stuff. It changes to bean launched is the new value, and we're going to let it run.
Is that like Mr. Bean or Ben?
Ben, as you call it, Ben launched.
Okay.
Yeah.
All right.
And then we're going to suspend our application. And then I'm going to go to the applicator here, and oh, not that.
I hope you picked the right one.
I know. This is it. It's the trouble. You get lots of variants of the same app. Lifecycle is the one we're working on.
Oh,
yeah.
perfect.
There we go.
It's only one of those.
So I'm now going to launch what would normally be a new instance of the app. Hey, look at that. We're not in application launching. We're in application activated. So actually what has happened here, so what will the app state variable hold?
Bean launched?
Oh, give that man a cigar. Absolutely. That's exactly what it is. Because it's reactivated the dormant one. So this is a change. So the reason why this application does this is because, let's just close it. The way you enable this miraculous behavior is, this is in the app manifest. Now, normally, as you've seen so far, we've got this nice GUI. This is one of those things where you actually have to go in and edit it. You have to open it with the XML text editor. It says it's already open. That's because the GUI editor is open, so it closes that. And here we go. This is the innards of one of these guys. The important thing here is this element here, tasks. So normally that bit wouldn't be there, but this application has activation policy equals resume as being added to that default task tag, and that is what turns on this fast application resume behavior. So we get fast resume, loads it back into memory, and life is all good. It's fantastic. Right, back to the slides. So that's what we do. We just simply change that default task to enable the far behavior. And I've got a diagram. Oh, what happened with there? It went a bit wrong. There we go. So there we go. So I've got key bounce on my thing. Yeah. So here we go. We've launched our app. We're on main page. We're on second page, and this is the standard app relaunch behavior. Then we start the calculator, and we get dormant, and then we start our app again. You get a whole new instance. I'm getting key bounce here. There we go. Oh, there it goes. Our old instance is deleted and our new instance is created. But the fast application resume, here we've got our app has been dormant, and now we're going to try and launch that app all over, and instead of a new one being created, our old one gets reactivated. So that's what it's all about. It's very simple. So, great, huh?
Are there any caveats, though?
Well, yeah, that's why this slide says, sounds great, so why don't I use far with all my apps?
I hadn't even read this.
Yeah, well, so here's the deal. Used carefully, great, fantastic. It's a good idea. So, but you do need to be careful about the user experience. So remember, when an app gets resumed from dormant state, we've got our entire page histories in there, all the variables are just as they were left when they were suspended and that sort of thing. Now, and that's fine, but when the user launches an application from the program menu, it's going to launch into the main page.
Right.
So you end up with this wacky page history stack, potentially, because they might have been on page 1, page 2 when it was suspended, and on a normal reactivation from dormant, it would come back on page 2. But on a fast application resumption, you've got the old page history will still be there, page 1, page 2, but then you'll have a new instance of page 1, or main page, if you like, on the top, which is the new page that you're going to launch on. So then they hit back, like you suddenly end up on page 2. It's like,
and they might expect it to...
Exactly. So you've got to think about the user experience very carefully. So that's kind of thing. But you need, and also, like I said there, when you do launch, you can think of it the other way as well. So when the user launches from the main menu, they might expect to go to main page. You could actually you could make use of this behavior to actually resume them exactly where they left off. And maybe for certain applications, that might make sense. Depends on the scenario. There's no right or wrong with this one. It could be that they were suspended on page 2, and even when they launch from the application menu, maybe you want to go straight back into page 2 and pick up where they left off. But be careful, because that would be inconsistent with the way that some of the other apps work. So, you've got a lot of things to think about what the application experience is going to be here.
Definitely lots of extra stuff to think about. It's not a slam dunk.
Now, the phone team, are well aware of this potential for causing chaos and confusion. So what they've actually done in all the project templates have already been instrumented, have already got code in them to handle this fast application resumption. And what they do is this. If we go back to the slides. First of all, you can detect a far resume, because it comes up with this fancy navigation mode. We saw navigation mode.forward and navigation mode.back before. There's a new one called reset, which you can look for and know you're being fast application resumed. And what the actual project templates do, they already have code in there to look for this. And this is code that's taken from app.xaml.cs. So you can look at this yourself. Just create any new app and have a look at it. And it hooks the rootframe.navigated event on in your startup logic, and the event handler for that is this thing called check for reset navigation, and you can see it there, and it's looking there for a reset navigation mode. So we're saying, hey, okay, are we doing a reset navigation? It then just temporarily hooks the rootframe.navigated event to another event handler called clear backstack after reset, and the clue's in the name.
Yes.
Yeah. So what this does, when we go forward, here we go. Ooh.
Oh.
So clear backstack after reset, it undoes that rootframe.navigated hookup again.
Are you using a stack panel on that? Or never mind. Scroll? Yeah, never mind.
Never mind. And then what it does is if we're in a reset navigation, what it does is that bottom line, while rootframe.removeBackEntry does not equal null, do nothing. So what actually that is doing is clearing the page history stack.
Okay.
So what it is doing is making sure that when you do a fast application resumption, what actually happens is any page history stack that's left over from the previous instance of the app is blown away. So what you're doing here is giving a fast application resume app exactly the same behavior as if it had been launched afresh from new.
Okay.
So they've gone for the consistency with other apps approach.
Sure.
But that's nothing to stop you taking that out if you want to enable this other behavior. So give it some fancy navigation. You can actually resume a suspended app. So
use with caution.
Use with caution. Lots of fun there.
Yeah.
So there we go. Programs can be launched from new or activated from dormant or tombstoned. We've got this state storage object and navigates to the correct page when activating an application has been running. So if we're coming back from tombstoned, but you have to do the logic to repopulate the forms. We saw that with using the state dictionary. We can run programs behind the lock screen by disabling this idle timeout, but this is strong magic, so just be careful. Use only when you need to. And the fast application resume feature gives you the option gives very fast startup. If you've got an app that the user likes a lot and you may have a dormant version of it running there, then you can have a very fast startup and take advantage of that and reactivate that. But you need to be careful, of course, of making sure that the user experience is clear and they understand what's going on.
Absolutely.
So
great stuff.
All right. So that's the application lifecycle. There's a little bit of stuff in there, but yeah.
It's good to know.
Yeah. So the key things is just to make sure you serialize your data on deactivating and on closing, and you do the right thing when you're being activated and under those different situations.
Or maybe even sooner.
Or even sooner.
You know, if you need to serialize 30,000 objects, you might not want to wait till the last minute. It might not happen in 5 seconds.
No.
Yeah.
Good.
All right.
So there we go. We're going to take a, what have we got, 10-minute break? We've got a 10-minute break.
All right.
And we'll get some of your questions while we're out as well. So thanks very much.